Hi everybody. I'm going to take a few minutes here to go through the answer key and give some comments on each question. I try to make one video for each marking period worth of material. So these are just going to be the highlights just to give you an idea of what's going on. The answer key should be pretty self-explanatory. So we're going to start out by talking about sequence and series. So this question here is talking about an arithmetic sequence. Now, a sequence is just a pattern of numbers like 1, 3, 5, 7, and the arithmetic refers to the pattern as addition. So on this problem here, they're just giving you this information, and all you have to do is fill it into the arithmetic sequence formula and solve for the ninth term. They're actually asking you on this problem to find the ninth term. So a sub 1 is the first term, which is -5. D is the common difference. It's what you're adding each time, and it doesn't really matter if you put the 4 behind the parentheses here or in front of the parentheses. It's still multiplication. And we're looking for the ninth term, so plug in 9 for n. That's pretty straightforward. Now, number 2 is also an arithmetic sequence. You can tell because you're adding by 4 each time. It's going up by 4. But this time, they're telling you what the term is. They're telling you 97 is the term, and they want to know what the n is, what position it is. So here you're actually solving for n, and you're going to plug 97 in for a sub n. So the formula is the first term, and then plus, remember, you can put the 4 out front, times n minus 1, and then you just want to solve for n. This next problem about the brick patio is actually an arithmetic series. And the difference here is that we want to know how many bricks are in the entire patio. So we're adding up every term in the sequence, which makes it a series. So this formula requires you to know how many rows there are, how many terms there are. In this problem, how many bricks are in the first row and how many bricks are in the last row. So you can see that there's 18 rows of bricks here. In the first row there is 14 bricks, and in the last row there's 31 bricks, so you're just filling that in and using the arithmetic series formula. Next problem is another straightforward problem, just geometric sequence. Again, they give you the first term, which is -6. R is what you're multiplying by each time, so they want you to multiply by -2/3. And they're asking you to find the first 4 terms. Now, you could use the formula, or you could just write the first term and start multiplying by -2/3 each time to get each additional term. If they had asked me to find some other term down the line, maybe the 10th term or so, then I just would have plugged in 10 in the formula. So you don't have to use the formula here. You could have used the formula. Next problem is a geometric series. You can tell that because it tells you it's a geometric series, or the plus signs between the terms here, and as well as the pattern is multiplying by a half. Remember with R has always got to be in terms of multiplication. So if you're not sure how to find R, you can always just figure it out by doing the second term divided by the first term. So in this case, 80 divided by 160. Well, that didn't come out very well. 160. Well, you get the point. 80 divided by 160, which is 1/2. So when you fill in R, it's always got to be in terms of multiplication. So R is 1/2. A sub 1's the first term, 160, and n, they want to find the sum of the first 6 terms. So you're plugging in 6 for n. It's just plug and chug. Down here we have some sigma notation. This means the sum of. This is a series. It's the sum of this sequence right here. Sum of a sequence is a series. So to use sigma notation, you start with this bottom k and you plug that in for k. So you start by plugging in 1 for k, and that gives you the first term. Then you're going to keep plugging in k's until you get to this top number. So on this problem, I'm going to plug in 1, 2, 3, 4, 5, and the last number I'll plug in is 6. And then you take all those terms and you simply add them up. So all sigma is a series, and you're just adding up all the terms. Start with the bottom k, plug it in all the way to the top k, and add all those terms up. So writing it out like this is expanding, and adding them all up is actually evaluating. Down here they're asking you to figure out, Melanie thinks that the series is arithmetic, Bobby says it's geometric. Just check out what the pattern is. We can see that the pattern's up by 4 each time, and that makes it an arithmetic sequence because the pattern is adding each time. 1 and 2 here is more sigma notation. Again, start with the bottom number and plug it in all the way to the top number. Notice number 1 actually starts at 5. They wanted to start with the 5th term. Number 3 here is an arithmetic sequence. You can again tell by the direction or that the pattern's +3. So to find the 15th term, you just want to create the formula, plug in the a sub 1, plug in D, and then you're going to plug in 15 for n and come up with everything. So reading this problem here, that you're stacking canned goods in a row. The top row has 6 cans, and then you're one more each row above that. So that means it's arithmetic because it's going up by 1, and they want to know what's in the 43rd row. So the first term is 6 because there's 6 cans in the first row. The pattern is up by 1, and they want to know the 43rd term. So n is 43, and this is just plug and chug from here. Number 5, we're just using the geometric sequence formula, a sub 1 times r to the n minus 1 power. Just remember when you put this in your calculator, you probably want to do the 5 minus 1 calculation on your own to avoid any mistakes. Let me scroll up. Number 6 here, what's the common ratio? Again, you can just do the second term divided by the first term, and that'll tell you what r was. So r is 1/2. So even though the pattern, wow, that did not come out. Even though the pattern is divided by 2, with geometric, we always have to think about it in terms of multiplication. So 5 over 10 is 1/2. So even though the pattern is divided by 2, r is always in terms of multiplication. So it's 1/2. There, got a little bit better there at the end. Alright, let's see if we have any more questions here that have to do with sequence and series. Here's one more, 2 more over here on the right. Number 19. Find the 50th term of the sequence. So on this one they didn't tell us it was arithmetic or geometric, but check out the pattern. It's +3, so it's arithmetic. 4 is the first term, d is the common difference, that's the pattern, and they want the 50th term. Just plug and chug. Here they want the sum of this arithmetic series, and they want to know the sum of the first 31 terms. So I need to know the first term, the last term, and how many terms there are. Well, we have the 31, and we have the first term. We don't have the last term, so we have to go back to the arithmetic sequence formula to figure out what the 31st term is, and then once I get that, I plug it in over here into the arithmetic series formula. Let's see if we have any more. One more. Down here, they're talking about school auditorium. The first row has 12 seats. The second row has 16 seats. The third row has 20 seats. You can see it's going up by 4, and that makes it an arithmetic sequence. So the first term is 12 in the first row. The pattern is up 4, and they want to know how many is in the 19th row. So you can see that'll simplify to A. So let's go through the probability, counting principle, permutation, combination problems next. Over here, this is kind of a little bit to see. It's probably clearer on your answer key, but here we're doing a counting principle problem. How many 7-digit phone numbers can be formed if the first digit cannot be 0 or 1 and digits can't be repeated? Now remember, there's 10 total digits. Don't forget about 0, 1 through 9, and 0. So the only real restriction here on the first digit is that it's not allowed to be 0 or 1. So that takes 2 options out. That's why that's 8. Now I'm also not allowed to repeat digits. So no matter what, I'm only picking 1 digit for this first number, which will leave me with 9 choices for the next digit in the phone number. And then I've already used 2 digits here. That's why this is 8, and then it'll just keep going down. Remember, counting principle is always multiplication. So you're multiplying these all together, and this is how many ways there are. Now here we're choosing from a group. Anytime you choose a few from a group, it's either going to be a permutation or a combination. You just got to ask yourself if order matters. So does it matter what order I pull the books from the pile in? Will it be a different choice if I grab them in a different order? And the answer is no. This is a combination because order does not matter. So it's 9, choose 4 as a combination. So if I was doing the math for this, you'd set up your 4 blanks, and then you would go down from 9 times 8 times 7 times 6 times 6. I know, that's a tough one for you. There you go. So you multiply those all together. Now, because this is a combination, we have to divide by how many terms there are factorial. So you can see we're picking 4. So you have to divide by 4 factorial. And what that does is it takes out all the repeats that aren't unique because order doesn't matter. So underneath here should be 4 exclamation point 4 factorial. Now number 3, you're picking 5 from 9, but you're lining them up in a row. And because a row has order to it, and if you switched people in the row, you'd get a new choice, this is a permutation. So all you really need here are the 5 blanks because you're picking 5. 3, 4, 5. You'll have 9 choices for the first person. Then you'll have 8, 7, 6. It does not like numbers. 5. Meh. What number is that? Anywho, you get the idea. Multiply these all together, and that's where this term comes from. So the next one, you're creating a pin number. It's got to be 2 letters followed by 2 digits, and you can repeat because they said you can't. 26 letters in the alphabet? Yes, you have to know that for the final. So 26 choices for each letter, 10 choices from each number, and just multiply them. Let's roll down here. Looks like we're doing some probability now. So let's see, a debate team surveyed, and their question is, what's the probability that someone's younger than 16? So the first thing you do is figure out how many people they surveyed, which was 15. And then you want to figure out how many people are younger than 16, which is 7 out of 15. The answers are in decimals, so just divide that in your calculator. What's the probability of a coin and a number cube that the coin shows tails and the number cube shows 2, 3, or 4? So this is more than one event occurring at a time. So you're going to multiply the probabilities, because when you multiply probabilities, when you multiply fractions less than 1, the fraction gets smaller. So obviously if they're asking you to do 2 separate tasks at once, it's going to be harder to do. So the probability of flipping tails is 1/2. And the probability of getting a 2, 3, or 4 would be 3 out of 6 on a die. So you just multiply that. You could actually simplify the 3/6 first, and then it's 1/2 times 1/2, which is 1/4. Now here we're asking a probability of picking a red card or a number less than 5. So you're only picking once. So this or right here means that we're going to be adding the probabilities. So there's 26 red cards in the deck, and there's 12 cards with numbers less than 5. Then you have to ask yourself if there's any overlap between red cards and numbers less than 5, and there are. There's the 2 of hearts, the 3 of hearts, the 4 of hearts, the 2 of diamonds, the 3 of diamonds, the 4 of diamonds. So you have to subtract out that overlap because we double counted it here and here. Down here, a heart or a 10, there's 13 hearts and 4 tens. Are there any hearts that are 10s? Yes, there's one, the 10 of hearts. So subtract out the overlap. So when it's or, you're adding, and just be careful that you subtract out any overlap. Scroll down. A die is rolled. Notice it's rolled once, so we're not multiplying probabilities here if you only roll it once. What's the probability it's both greater than 2 and even? Well, on a die, that only leaves you 2 choices, a 4 or a 6. That's 2 choices out of 6, which reduces to 1/3. Number 9, you're picking now more than one card without replacement, which means you're not putting it back in the middle. So the first time you'll have a probability of picking a 7 would be 4 out of 52. Now, no matter what, you're going to pick a card. So the next time there's only going to be 51 cards in the deck, but there's still going to be 4 kings in the deck, so it's 4 out of 52 times 4 out of 51, which reduces to 4 out of 663. Number 10 here, you're making a, oops, we lost it. Come back. There you are. We're making a Social Security number where the digits can be repeated, but the first digit may not be 0 or 9. So that's the only real restriction. That takes out 2 choices. That's why that's an 8. It is, a Social Security number is 9 digits. That's why there's non-blanks. So there are only restrictions on the first digit. Everything else has 10 choices, so just multiply those together. Scrolling down here, how many ways can you arrange 7 different books on a shelf? Well, you'd have 7 spaces because each book would get a space, and then the choices would be diminishing. You'd have 7 choices for the first 7 choices for the first book. That is not 7. Wow, this is harder than I thought it was going to be. 7 times 6 times 5. Wow, this is weird numbers. Times 6 times 5 times 4 times 3 times 2 times 1. And that's just 7 factorial. Now you can see why they use an exclamation point. Obviously, I can't even write this out. Next one, you're choosing 5 people from 10 to be on a starting team. Without regard to position means that you're just picking 5 people. So order doesn't matter. So that makes this a combination. So there's 5 to choose from. And it's going to be diminishing. You'll have 10 choices for the first person, then 9, 8, 7, 6, There you go. And then you got to divide by how many you're picking factorial, which is 5, so you divide by 5 factorial because it's a combination. Number 13, you're throwing 3 cubes. Your probability that they all show the same number. Well, the first time it doesn't matter what the first cube shows because you're trying to roll any number 3 times that they show up all the same. But then the next time you have to match the number you rolled the first time. That's why those are 1/6, and you multiply those together, you get 1/36. Down here, we're picking letters out of a bag that have the letters from the word Mawa High School on it. So we're talking about or, we're only picking once, so we're adding probability. So again, just worry about overlap. When I say vowel or the letter O, well, letter O doesn't add any options because O is a vowel. That's why these are exactly the same and cancel each other up. That's the overlap. There's 2 O's that are vowels. Between picking a letter H and M, there's no overlap. There's no hybrid HM. That's why we're not subtracting everything out here. Now we're picking 2 cards. That's why we're multiplying. This is with replacements, so we'll put the card back in the middle. So that means the first time you have a probability of picking an H of 5/16 because there's 5 H's, 16 total cards. And since you're putting it back, the next time the probability will be the same. And then you just multiply those. There's only a couple questions left. Oh, there's another one down here. In a class of 30 students, how many different groups of 8 students can be picked to eat lunch together? Well, you're just picking a group. That's why it's a combination. So you'd have 8 blanks on this one. Working your way down from 30, 29, 28, 27, 26, etc. And then you divide by how many you're picking factorial. So here you divide by 8 factorial. If a die is tossed, what's the probability of it being an even number or a number greater than 4? Again, you can think about this logically. How many even numbers are there greater than 4? And just be careful of any overlap here, because if you pick even numbers, there's 3 out of 6. If you pick numbers greater than 4, there's 2 out of 6, but there's 1 overlap, which is the 6, so you subtract that out. Or you can just use common sense and write down all the number choices that this would involve, and then over 6. So a couple more up here. Number 15, you're tossing a coin and a 6-sided number cube. So the probability you rolled an odd number on the number cube would be 3 out of 6, or 1/2, because half of the numbers are odd. And the probability of you getting tails would just be 1/2, so you multiply those together. On this problem with the license plates, so it's 3 letters followed by 3 numbers, and everything can be repeated, so the only restriction is the first letter cannot be something got cut off or Z, so 2 letters are out. So that would be 24 choices, but then everything else is fine. Picking a committee, 15 choose 8. This is a combination because it doesn't matter what order you choose in to get a committee, so this would be 8 blanks with 15 times 14 times 13, etc. divided by 8 factorial is how you get that. What's the probability a number rolled is greater than 2 and even? So you're looking for 4, really basically just 4 and 6, and you're only rolling once, so that's just 1/3. So that's a look at the first unit of the review packet.